Now I'm coming in from the left. I'm coming in with a number, and this is the thing that makes limits a little bit more difficult. I'm coming in from the left, which means that I am coming in from a number which is smaller than 2. Right? That's important. This guy is smaller than 2. He's smaller than 2. Now, why would that be important to me? Because if I put in x equal 2, what do I get? 0. If I were to pick a number bigger than 2, what would happen?
Get a negative number.
I get a negative number under the radical.
Which gives you
an imaginary. Yeah, and that's not a limit because it's not real number. Limits are only real numbers because they're stuff off of graphs. They're y values. And i's not a y value ever. That's why this guy is only coming in from the left. Because if you pick a number bigger than 2, you're going to end up with this number being bigger than 4. Because at 2 you get 0. At 2.1, what are you going to get? I'm going to get 4 minus and 2 times 2.1. I get a negative number. But as long as I'm to the right of 2, or left of 2, like 1.9, I get a positive number. And that makes a difference. So that's why you have to come in from the left. So then the next thing is, you know you're not going to actually get to 2, but how close to 2 are you going to get? As close as you as possible. So if I wanted to do an evaluation, and this would drive math majors crazy, I'm going to look at, well, what would be 4 minus 2 times 1.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nines? What do you think that would be? Yeah. So 4 subtract 2 times 1.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nines. 2 times, should get my color calculator out, it'll be better. 2 times 10 to the negative 10. So it's going to be 0.9 zeros and a 2. So that is very close to what number? 0. Can it ever be 0? It's a question. Could it ever be 0? Yeah, I can put 2 in. Does 2 make sense in this problem? Yeah. Something smaller than, something bigger than 2 does not. So that would say, if I test this out, this is essentially equal to then 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 2. And if you were to take the square root of it, this is approximately 0. So what would you say that the limit of this is? 0. That's the game you play, by the way. That's the game you play. Pick a number very, 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 very close. See what you get. In this case, x equal to does make sense, but to the right of 2, it does not. But to the left of 2 it does, which is why you have to stay to the left and pick a number that's very, very, very close. If you pick a number that's very, very close, you're going to get essentially what that limit is for all intents and purposes. I'm going to pull my color out. This guy projects. Let me see. See how it projects so much better. The color one does. Okay, oh, what about this guy? 2 from the left. By the way, 2 from the left and 2 from the right are going to be completely different. At x equal to, what would I have? 2 squared plus 4 over 2 minus 2, which is 8 over 0, which is undefined. And what does that mean to us, really? If I have a pure division by 0, what is it? It's an asymptote. What kind of an asymptote? At x equal 2,
Vertical.
we have a vertical asymptote. Now, we know the behavior of vertical asymptotes. Behavior of vertical asymptotes, if this were 2, I either have it going up on the left of 2, or I have it going down to the left of 2. One or the other. So guess how I solve this problem? What would I do? Pick a very number close to the left of 2, right? That's really the easiest way to do this. And then see whether I get a positive number or a negative. Is this sucker going up or is this sucker going down? No. So I'm going to test. Well, let's do our 1.9999, see what happens. Well, that's going to be easy enough, isn't it? Because if I look at 1.9999 squared plus 4 over 1.9999 minus 2, what's this guy? Is he positive or negative?
Negative.
He's negative. What about the numerator?
Positive.
It's positive. So positive divided by a negative is negative. So what is he doing? What is he doing?
Going down.
He's going down. Because this guy's in control. Numerator is always positive. So I could say that the limit as x approaches -2 of this guy is what? If he's going down, it is negative infinity. When you're dealing with vertical asymptotes, you're either dealing with positive infinity or negative infinity. It's negative infinity.
For the text, can we just graph it and then use
No.
that?
You can answer your question that way. What if you had something that didn't graph that easily?
Can you look at the table and look at all the numbers?
You can look at the table, but then you include it on your work. There has to be work behind it. You know, how did I know whether or not it was a good guess or you really knew what you were doing? So if you want to table it, you can table it. That's fine. But I don't want to, you know, I really don't want you doing it graphically. So I want it more numerical than anything else. So it's going to negative infinity. Now what about this guy? I know, oh, ooh, mmm, mmm. What's the problem?
Zero, it has to be 0 to 1.
0 over 0 form. 0 over 0 form. If I plug it in, I would get 1 minus the square root of 1 over 1 minus 1, which is 0 over 0. And all this says, I don't know what the stinking thing does. It might go to a number for all I know. I don't know. It could go to plus or minus infinity. Don't know. All this says is, don't know.
Is that a acceptable answer on the test?
Nope. Unfortunately not. I don't know. What I have to do is what?
Pick a number close to 1.
No. What do I have to do is what?
Pick a number that doesn't make sense.
Anytime you have 0 over 0, what do you need to do?
Algebra.
Algebra. And what algebra am I going to have to do? See, this is why you have to do homework. Because otherwise, when you hit stuff, you're not going to know what to do. What algebra am I going to have to use? Begins with an R. Rationalize the, not the denominator, numerator, because that's where the radical is. Now I'm going to leave the denominator alone. So x times x is x squared. Inner outers add the 0 minus square root of x times the square root of x is x. So now factor out a greatest common factor of x. And I'm going to get x times x minus 1. X minus 1 times x plus the square root of x. So this becomes x over x plus the square root of x. Now we try it again. Take the limit as x goes to 1 from the left of x over x plus the square root of x. Does 1 now cause this guy a problem at all? No. So that says I can just plug it in. It's where I have a problem that I've got an issue. This becomes 1 over 1 plus the square root of 1, which is 1 over 1 plus 1, or 1/2. That says this sucker's coming in at a hole. Remember? I divided out. When I divide out the factor, it creates a hole in the graph. He's coming in at a hole. And the y value was 1/2. And that's hard to see from graphs, because there's no y value there. If you try to get it, it says there isn't any. Yes, there is. Well, Howard and Harriet is close enough to call. Actually, he's getting very close to that. And because this comes out to be a numerical value, she's going to be there too. Because 1 didn't cause a problem anymore. Cool, huh? Maybe not.